Hi and welcome. Actually, this video is an update to the previous video, if you just watched, of my review of the KAIWEETS KM401. They also had several other models they were going to ship me. I had the 401 shipped to me 10 days ago, and strangely enough, the very day I post the video, that evening, the other two arrived. So I'm going to look at all three together, and I guess you'll already have guessed by now that I lost my mic during this process, so I'm going to narrate what we're looking at here. They basically had three models they wanted me to look at. The first one is auto ranging. The second one here, one of the new ones, is a fixed scale uh, multimeter. And the last one is sort of an automated meter that's sort of a copy of an electrician's wiggy, although it's a lot smaller and it's not quite designed the same, but it's sort of in that shape and vein. If anyone doesn't know what electrician's wiggy is, it's a multimeter, a very simplified multimeter that electricians use basically to see if voltage is present and measure basic voltages while they're doing setups. All right, let's just open these guys up. They have a sealed for your protection seal on each one, which is more plastic for the landfill, sadly. We're really addicted to that sort of thing. This fixed range multimeter is similar to the 401, and it's the 402, so you think it would have more features. It actually has fewer features. Like, for example, it doesn't include the temperature probe. Um, as you will see, it's basically the meter just like the other one, the same form factor, same very nice probes, batteries, and a manual. The KM401 I looked at previously had a manual in multiple languages. This manual is just in English, which I think is kind of interesting, as if it's targeting an American-only audience, which is unusual. The previous manual, as you can see, is in multiple languages, and that makes sense if you're going to do a worldwide release. This one maybe just targeting the US market. Weird. The smaller one is very simplified, has a manual in multiple languages, targeting multiple audiences, obviously, and the unit itself has the probes built into the unit itself. They're not removable, so if they break, you're out of luck. They also include batteries, which I think is a really nice touch. I think all these meters, when they come with, you can use them right out of the package without hunting for batteries. It's a nice touch. Again, too much packaging, but you know, we're addicted to it and probably wouldn't buy it if it wasn't nicely packaged. The little guy, the 201 and the 401, both come with flashlights on the front, which I never bothered testing because I don't even use that feature. Don't predict that I'm going to have that in a meter, but the 402 does not. Just like the previous model that I reviewed, neither of these have captive screws, nor do they have magnets on the back to hold the meter up when you're working in a panel. And I think that would be a really nice touch. And I think I would certainly be willing to pay $1 or $2 more to have that included. But apparently they did not, and I think they should consider it. Also, without captive screws, when you lose the screws, neither of these back plates snap into place. So you're really risking having to tape the back panel on or find another screw, which is unfortunate if you lose it, which is likely.
So these two meters, I think, are based around the similar chipset, or if not the same chipset completely. Even though they don't have all the exact same features, they're very similar. And when you look at the accuracy, it's listed identically, so 0.5% for DC voltage, 0.8% for AC voltage. This one's a little less accurate, 0.5% for DC, 1% for AC plus 3 counts. And resistance-wise, they're identical across the board. Is that right? Let me see. Resistance 1%, 1.5%. Yep. This one doesn't do capacitance. It doesn't do frequency. Things you probably wouldn't need. Current-wise, these two are identical. Is that right? Yep. Yeah, current-wise, these two are identical. This guy doesn't do current. This one really is for an electrician that's working in the field, so it doesn't have these measurements that you wouldn't need. This also is only rated to 600 volts. This is rated to 1,000 volts. So that means inside here they put some safety gaps and things for arc over, and the arc over spaces should be bigger on this one than this one internally. The probes of this one are not quite as nice at all as these two. This one is designed for size and convenience. These meters have a physical switch for power, which means that when they're in off position, the battery's disconnected, ideally. I mean, I don't know what they did internally, but I'm guessing that's what they did because that would just make sense. This guy is a soft switch for power on and power off. And with a soft switch, that means it's always got to have a little current flowing to detect when you push that button, which means these batteries will go faster. That's just a minor quibble, something to be observed if you want to put something. Personally, I always go for this style. Even if I was an electrician, I think I'd still go for this style, even though I wouldn't necessarily need all the features, because I could just stick this in my bag, and when it's off, I know the battery's not draining, going down. And this one, you know, if you have a bag stowed for a while, it could go down. This is a 2,000 count meter. These are 4,000 count meters. So it gives these a little more range and accuracy in each scale. Double, I guess. Why don't we hook these guys up to some various measurements and just see how they perform relative to each other? That's kind of interesting. We know that this is not a super accurate meter, although it's better than their stated accuracy, based on some of the measurements I made. So they're well within spec. But you know, it's not a precision bench meter if that's what you're looking for, but for 20 bucks, you know, you're really not looking for that anyways. So this guy, even though it's an auto-scaling multimeter, some of the auto-scaling multimeters like the Fluke, you hit the range button and you can manually force it to go through the ranges. This one does not have that feature. It's auto-scaling all the time, so you can't control when it changes. This one, if you like the fact of wanting to control what scale you're in for sure, has that option built in because it's individual scales directly picked up. Hopefully the meter has a good amount of protection in there to protect in case you go over voltage, especially when you're measuring voltage. Like if you're in the 40 volt scale and you hit a kilovolt on there, hopefully it protects it. I don't know. That's an interesting question. That could be a problem in a manual scale meter. So you need to know roughly where you're at, or you need to always start on the highest scale and then work down. So this guy, it would make sense that if you're connecting something you're not familiar with what the voltage might be, you start high on the 1,000 volt scale, go 750, 444. That's in the AC scale. It's not really obvious when it switches between AC and DC. This the measurement. What measurement you're actually doing is a little confusing on the outside here. This would be DC 400, and you go the opposite way to go down 40 and 4 and then 400 millivolts. It would make more sense to have them both going from the largest voltage on down. That's really odd to have it two separate directions for the same thing, or counter or clockwise to go down in one, or counterclockwise to go down in DC. That's just really odd. I don't think I would have made that choice. All right, so last time when I was looking at this meter, the 401, when I was reviewing this, I noticed there was a non-contact voltage in a live setting, and I didn't make the distinction between the two. So the non-contact voltage section uses the sensor here on the end. All three of these have that. The live uses just the plus probe like it does in the phase mode to detect to see if there's a live circuit there. So this is plugged into the AC outlet, and this is the hot. Let's see who can detect. You see that delay there? So low means it detects a low electric field. The 402 is more sensitive than the 401, so maybe there's something up with the 401 here. I'm kind of curious about that. Now it detects high, high, high. So all three of them seem to be working there. These two seem to be more sensitive than this one by a little bit. Maybe I just got a defective one. All right, so let's go to the live function. That's really interesting. So switch to live, and does this one have live? This one does have live. All right, so live should utilize the positive probe. So let's see if I can get the right set of probes here. So this is the positive. Okay. That was the problem I was having with the phase measurement. How about this one? Now there's no current flowing through this, and maybe that's part of the problem because I gotta assume it's measuring the magnetic field, not the electric field, but yeah, not one of these was able to detect that. Let me go and put a load on this, maybe a little bit of a load, and see if that helps detect the difference. So as a load, I've got the power supply over here, putting out 1.5 amps into a load, and now we'll see if the AC side can detect anything. There we go, just barely. Not enough current draw, I guess. Just barely detects anything. This one, gave an indication briefly. And this one, not so much. All right, well, let's see if we go to something heavier duty, more current drawn, and see if it detects that. All right, so I thought we'd try and do a couple more measurements here. I'm in the live mode on this guy. This is my lathe and it's running. It's a 5 horsepower motor. And these are the primary leads coming in. And it does not detect current on any of them. Let's take a look at this guy here. Should be able to detect that it's live, but it does not. It does not. Non-contact voltage. It is detecting that. Takes a while. Non-contact voltage. It detects it on this guy. Non-contact voltage. This one is not detecting it. That's not so good. Going to the phase measurement here, you're supposed to use just the positive lead. And you're supposed to be able to find one of the phases. It does not. All right, this guy's in phase mode. It's flashing an A. Hey, it found one. Found the second one. Found the third one, and says it's going in reverse. Okay, this guy in phase mode. Here's the first one. Found it. Second one, struggling, not finding it. Not finding it, can't get it to work. So let's try this guy again. Here's in phase mode. This is coming close to phase number 1. And this thing is, the lathe is running, you can hear it in the background. So even with the current draw, it's not finding it, and that's a 5 horsepower motor. Let's go back to this one. This is the only one that I could get to work at all. So we're in A, it's flashing, it says find A, phase A, there we go. Phase B. Found phase B finally. And there it says the same thing. So it seems like that's working. So for the phase measurement, this one I really couldn't get to work again, even with the lathe running. And so 5 horsepower motor turning at high speed. This guy did work the first time and then struggled a little bit the second time and then struggled a bit the third time, but I was able to get the first 2, and the third I couldn't complete at all. I was trying to do the phases out of order, see if I could get it to go the other direction. This one got a couple of the phases and then couldn't detect the third phase at all. Don't really know why they're having so many issues with it, but bottom line is that I think this particular feature of the meters is not really soup yet, or there's something I don't know. I mean, I'm following the instructions in the manual and they're not giving me any hints about anything else I should do, but I don't think it's working too well. So this meter's full auto, voltage, continuity, ohms, all in one setting here. So I short the leads, and sure enough, you can tell when it shorts. I like the fact they've got probe covers, that's handy. If I pop it into an AC socket, 119, 120.1, very good. This guy, I'm kind of curious. So let's start overscale. Let's start 400 volts, 120.0, 60.2, 60.1 hertz. This guy, got to simply select AC. 120.0, 60.0 hertz. So I'm kind of curious now. Let's go back to the manual scaling multimeter. If I made a mistake and I'm looking at 110 and I go down to the 40 volt range, oh, it just says overload. Doesn't damage the meter. That's good to know. I would be really careful on the current scales though. That could be a definite problem. Resistance on this meter, let's see, go down here. There's diode and continuity. So 0.3 of an ohm, that's good. And there's the small ohm scale, 400. That actually reads 0, kind of interesting. This is measuring 0.2 volts. That's saying it's a 0.2 volt drop across this, which is kind of interesting because it's diode mode. But when you go to resistance mode, does it show any? Yeah, it does. Okay. Showing a little bit of resistance. It didn't the first time, but it did the second time. Kind of interesting. This guy, continuity mode. That's the voltage drop across the probe. Now it's down to 0. Let's go to ohms. There we go, 0.2 ohms. Okay, yeah, I kind of expect that. Here's all three multimeters in parallel. This one's on, so this says how you know you're on the wrong scale because you don't have enough significant digits. So I'm going to go down to the 4 volt scale. So 1.028, 1.027, 1.028. That's very good consensus there. Let's go up a little bit here. I'm over voltage on this one. At least you don't have a problem. You can flip up the scale, 6.82, 6.82, 6.82. Well, these are all calibrated to the same standard, it looks like. Look at that. That's pretty impressive. 201820. Okay, a little bit of difference there, not much. We're about to go over scale on this one. Go up to the next scale, 46.0, 46.0, 46.1. Not bad at all. Let me just give my overall opinion. So I'm back to this non-contact voltage and live testing, one that uses the probe, one that uses the little sensor here. The non-contact voltage works the best on these two. This one gets it eventually. It tends to work better when there's a load. So if you're looking at unloaded electric circuit, they struggle a little bit to find it. These two are much better than this one. Maybe this one's got an issue. The phase detection, I got to work on this one, partially on this one, not really on this one at all. I think that's sort of a gimmick. The live testing also sort of worked on this one, didn't work on this one, and didn't really work on that one either. So I think those are gimmicks. Don't rely on it. I'd say get your probes on there and measure the voltage just to be safe, especially if you're going to get your hands on that circuit. Don't trust the non-contact voltage measurement on any of these. I would take the probes and double check. Other than that, the accuracy is good. My personal preference is for the kind of meter that has a definite off position, so you're not killing the battery while you're storing it. But these are much larger than this unit, so if you want a little unit to throw in your bag and you don't do voltage measurements all the time, this guy's pretty nice. In this case, there's no magnet. In all these cases, there's no magnets to hold anything. I think it'd be worthwhile in their case if they spent like $1 or $2 more, put a captive screw and had magnets on all three of these. That would be a really nice improvement. My preference is for these two. Auto scaling is convenient. Temperature is a nice option, but I think overall I prefer this meter because I don't mind the manual scaling at all. And oh, by the way, this one has a battery measurement mode, and I assume that's for DC voltage measurement, which it is. And what that does is it puts more of a load. So normally a multimeter wants to be a high impedance load because you don't want to affect the voltage on the circuit you're measuring. However, when you're testing a battery, some batteries will measure fine voltage wise with a digital multimeter because it doesn't put any load on the battery. So it does, but the battery is actually failed. So the moment a load's actually on it, the voltage drops. Some of these will fake you out. This guy has a battery mode which puts more of a load on it, which then will allow you to get a better chance of finding out whether the battery's really dead or not. That's a nice feature. Only this one has that. This one has temperature that this one doesn't have, although you could put a thermocouple on this and measure the voltage. You just don't get the advantage of the compensation and translation into temperature that this guy offers. That's nice. This one, the weird scale where they've got counterclockwise for one for DC, clockwise for AC to go down in voltages. I think that's kind of weird. I think they should have been consistent with that. Other than that, I think these meters are all okay. I like this one the best. If I had to get one, this is the one I would buy. This one, I'm not a fan of this type of fully automatic meter that, you know, does everything for you, where you can't force it to be what you want it to be when you want it to be, so you know what you're measuring. So I would never get this personally, but for people that just want something quick and dirty for home, maybe that's fine. These are all about the same price. So personally, this is the one I'd go for. Anyways, that's just a little bit more of an overview. I thought I'd do a little more with the phase testing to see if I could get it to work at all now that I had more options to test with, to see if I was doing something wrong. Only this one worked at all. I wouldn't trust the non-contact voltage on any of these. If I was going to put my hand on that circuit, I would get the probes on there to make sure. I think you should do the same for sure. This one was pretty reliable on the non-contact voltage. This one was okay. This one was pretty good as well. But again, maybe that's just a rough indication. Then get your probes on there to double check before you do anything involving the circuit. And that's about it. There's lots of these out there, so you've got a lot to choose from. This one's my favorite. Thanks for watching. Hope you find it useful. Hope to see you next time.